So there are different ways to indicate which conditions do we need to be in the sustainable quadrant. This is one of the examples, the one that I showed you before. But now we're going to come up with another approach, and this approach is the planetary boundaries. This is an attempt to define a safe operating space for humanity by analyzing the intrinsic dynamics of the Earth system and identifying points or levels relating to critical global scale processes beyond which humanity should not go. The concept was introduced by Rockstrom and collaborators, and in fact, he has made a movie about planetary boundaries that is now on Netflix, and you should definitely see it to understand this concept in a better way. And it has also been now adapted and is constantly updated. The fundamental principle underlying a planetary boundaries approach is that a Holocene-like state of the Earth system is the only one that we can be sure provides an accommodating environment for the development of the humanity. For this, 9 planetary boundaries have been proposed, which, if respected, will likely ensure that the Earth system remains in a Holocene-like state. So the analysis have estimated quantitative boundaries for 7 of the Earth system processes or elements, including climate change, stratospheric ozone, ocean acidification, the nitrogen and phosphorus cycles, biodiversity loss, land use change, and freshwater use. For some of these, it is a first attempt at quantifying boundaries of any kind. That is, quantifying the supply of some of the regulating of the supporting Earth system services. There is insufficient knowledge at the moment to suggest quantitative boundaries for 2 of the processes: aerosol loading and chemical pollution. Rockstrom and colleagues estimate that 3 of the boundaries, climate change, nitrogen cycle, and biodiversity loss, have already been passed, while we are approaching several others. So there are some criticisms about the establishment of these planetary boundaries. And it is because, for instance, it has a precautionary approach. And the approach may not seem fair to less developed nations who are balancing the need to manage environmental impacts with the need to provide citizens with basic needs. So there are some, this is just one example, and I will not go into detail into the other ones because the concept has been widely adopted already, and it functions as a tool to quantify and to also for the implementation of policies. We're going to start discussing one by one each of the boundaries and the parameters that are being used to assess the boundary. I must tell you that the table that I'm showing you, where we say the proposed boundary and the current status, is constantly being updated. So you may have other values now, and this is the case now for climate change, where we already have passed 400 parts per million of CO2. And in this table, we are showing you 387. So let's start discussing stratospheric ozone depletion. This is the layer in the atmosphere that filters the UV radiation from the sun. If the layer decreases, the UV radiation will reach ground level. And this can cause not only skin cancer to humans, but it can also damage terrestrial and marine biological systems. You may have remembered the appearance of the Antarctic zone hole. That was a big call to have a change on the substance that we were releasing to the environment, especially the chlorofluorocarbons that were actually destroying this ozone layer. Fortunately, because these actions taken are as a result of the Montreal Protocol, we now are within the boundary, so we haven't passed the limit. Now we're going to start discussing loss of biosphere integrity. So this is biodiversity loss and extinctions. So the Millennium Ecosystem Assessment in 2005 concluded that changes to ecosystems due to human activities were more rapid in the past 50 years than at any other time in human history. increasing the risk of abrupt and irreversible changes. And the main drivers of this is food, water, and natural resources that cause severe biodiversity loss, and also changes in land use, and also changes in ecosystem services. These drivers are either steady, showing no evidence of declining over time, or are increasing in intensity. The current high rates of ecosystem damage and extinction can be slowed by efforts to protect the integrity of living systems. So that means the biosphere, enhancing a habitat and improving connectivity between ecosystems while maintaining the high agricultural productivity that humanity needs. So there is a need for further research to improve the availability of reliable data for use as the control variable for this boundary. Let's talk now about chemical pollution and the release of novel entities. Emission of toxic and long-lived substances such as synthetic organic pollutants, heavy metal compounds, and radioactive materials represent some of the key human drivers of change for the planet. These compounds can have potentially irreversible effects on living organisms and on the physical environment. Even when we uptake and bioaccumulate chemicals at sublethal levels, they have effects on reduced fertility, potential or permanent genetic damage, and can have severe effects on ecosystems. For example, persistent organic compounds have caused dramatic reductions in bird populations and impaired reproduction and development in marine mammals. There are many examples of additive and synergistic effects from these compounds, but these are still poorly understood scientifically. At present, we are unable to quantify a single chemical pollution boundary, and therefore we have insufficient data to conclude where are we in terms of the limits. Let's talk about climate change, and it's something that probably you have heard so much about it. But still, what we are going to just briefly say is that we already passed the boundary. We are at the point where the loss of summer polar sea ice is almost irreversible. And this is only one example, but there are other mechanisms and other dynamics that are being disrupted. Let's talk about ocean acidification. When will be talking about CO2 or climate change, we will realize that oceans are the ones that capture most of the CO2 of the planet. So it is captured in form of carbonic acid, and if we alter the chemistry by acidifying oceans, this carbon will be released. This increased acidity reduces the amount of the available carbonate ions. So beyond a threshold concentration, this rise in acidity makes it hard for organisms such as corals, some shellfish, and plankton species to grow and survive. Losses of these species will also change the structure and dynamics of the ecosystems in the ocean, and they can also affect, for instance, fish stocks. Unlike most other human impacts on the marine environment, which are often local in scale, the ocean acidification boundary has ramifications for the whole planet. It is also an example of how tightly interconnected the boundaries are, because you see the connection between climate change, that is related to CO2 emissions, and ocean acidification. So this is how they are linked to each other. So let's talk now about freshwater consumption and the global hydrological cycle. This is something that you will discuss in detail in one specific lecture for it. But very briefly, we can now discuss that it has been affected by climate change, and human pressure is now the dominant driving force for determining the distribution of global freshwater system. As an example, nations put dams and they can stop the flow of these freshwater systems, which can affect other ecosystems around the area and can have significant effects on the matter and energy flows. Another consequence of human modification of water bodies is the vapor flows arising from land use change. And these shifts in the hydrological system can be abrupt and irreversible. And again, this boundary is highly connected to land system change. So let's talk now about one of the most important and dramatic changes in the planet, land system change. Land is converted to human use all over the planet, and we're affecting wetlands, grasslands, forests, and all types of vegetation. And we are converting this to agricultural land. The land use is changing now and is now the driving force of biodiversity. At the same time, this also has impacts on water flows and on the biogeochemical cycles of carbon, nitrogen, and phosphorus. While each incident of land cover change occurs at local scale, the aggregated impacts can have consequences for Earth system process at global scale. A boundary for human changes to land systems need to reflect not just the absolute quantity of land, because that's the thing. This is not cannot be measured in total numbers. It has to be considered spatial distribution and function and quality. So, for instance, forests cannot be considered the same as deserts or as other type of lands of ecosystems. Let's now discuss nitrogen and phosphorus flows. The biogeochemical cycles of nitrogen and phosphorus have been radically changed by humans. Nitrogen and phosphorus are both essential elements, and therefore we normally talk about these elements in terms of fertilizer loads, right? Human activities now convert more atmospheric nitrogen through the Haber process into reactive forms that are being used in the system, in the earth. And much of this new reactive nitrogen is again emitted to the atmosphere, and when it rains, it pollutes waterways, coastal zones, and accumulates on the terrestrial biosphere. Similarly, phosphorus is a problem. It is taken by plants, but is also mobilized by humans, and also at the end it finishes in aquatic systems, and this can deplete oxygen in lakes and freshwater systems because bacteria consume the blooms of algae that grow due to the increase in this nutrient. A significant fraction of the applied nitrogen and phosphorus makes its way to the sea and can push marine and aquatic systems across ecological thresholds of their own. And one key example of this is the dead zone in the Gulf of Mexico. This dead zone is called dead because it lacks completely of oxygen, and this was caused by fertilizer that was transported from the rivers in the USA. Let's talk now about atmospheric aerosol loading. An atmospheric aerosol planetary boundary was proposed because it influenced the aerosols of the air climate system. Through the interaction with water vapor, aerosols play a critically important role in the hydrological cycle, affecting cloud formation and global and regional scale patterns of atmospheric circulation, such as the monsoon systems in tropical regions. They also have a direct effect on climate by changing how much solar radiation is reflected or absorbed in the atmosphere. Humans change the aerosol loading by emitting atmospheric pollution. Many pollutants gases condense into droplets and particles, and also through land use change that increases the release of dust and smoke into the air. Shifts in climate regimes and monsoon systems have already been seen in high polluted environments, giving a quantified regional measure for an aerosol boundary. The reason why aerosols is a boundary is also because it can affect living organisms.